Hey guys, welcome to our special video lesson where I'm going to review the concepts from sections 6.3 and 6.4. In 6.3, we were first introduced to logs. So I want to remind you about the definition of a log. We have the log base b of y equals x if and only if b to the x equals y. So if we don't understand this relationship between exponential functions and log functions, we won't be able to really understand anything with logs. So one thing I want to point out is that our base is always the same. In a log, your base is in the basement, and in an exponential, your base is what's being taken to the power. Then when we switch between forms, the input and output switch. So if I look at my original, my y was the input of the log. It becomes the output of the exponential. And my x was the output of the log, and it becomes the input of the exponential. So that can go both ways. All right, so the first thing we did is we converted between forms. So let's first convert from log form to exponential form. And I'm going to go rather quickly since this is review, and you can pause this video anytime you want. You could even pause it before I give the answer to kind of quiz yourself while you're going through this. So number one, let's do log base 9 of 1 equals 0. And number two, let's write log base 6 of 216 equals 3. And we're going to write these in exponential form. When I do that, I first identify my base. So number one, my base is 9. And now I will write 9 to the, my output 0 becomes my input. So 9 to the 0 equals 1. Remember, anything to the power of 0 is 1. And thus any log of 1 is 0. All right, and number two, log base 6 of 216 equals 3. My base is 6. My exponent is 3, so it's going to be 6 cubed equals 216. All right, moving on, let's go the other way. Let's take an exponential and change it to a log. So let's say I have 13 to the negative second equals 1 over 169. With that, my base being raised to the power is 13. So I write log base 13, and I bring in that 1 over 169, and my output becomes negative 2. Trying another, I will have 4 to the 3 halves equals 8. So now my base is 4. So I write log base 4 of 8 equals 3 halves. Okay, so that was our first sorting target of 6.3. After we were able to switch between forms, we moved on to evaluating logs. And remember, we did these without a calculator. Evaluate means to find the value without a calculator. So for example, if I have just the log base 8 of 64, what I'm asking myself and what I think about is, to what power do I take 8 to get 64? And that would be 2, because 8 squared is 64. Let's try another. How about log base 2 of 32? So I ask myself, to what power of 2 do I take to get 32? And you might have to guess and check a little bit, but that would be the 5th power. 2 to the 5th equals 32, so log base 2 of 32 equals 5. So these numbers I'm underlining are my answers. Let's try another. How about log of 10? Now, I purposely did this one because I did not write a base. And you guys need to remember that when the base is not written, that is the common log. And that is base 10. Okay, so here I'm asking myself, 10 to what power gives me 10? Oh, that's easy. That's 10 to the first. So that is 1. And another thing to remember, whenever your base and the number you're taking the log of are the same thing, you're going to get out 1. All right, let's do a few more. How about log base 3 of 1 over 27? Here I am asking myself, 3 to what power gives me 1 over 27? Well, I do know a relationship between 3 and 27. I know that 3 cubed equals 27. But if I want to do the reciprocal of 27, I would have to make that a negative 3 for that exponent. So if I wanted to flip that around, I would have to make that negative. So this would have to equal negative 3. Just get rid of that. So this is 3 to the negative 3rd. All right. How about log of 0.01? Okay, I threw the common log in there again for you. But another thing I did is I gave you a decimal. And believe it or not, we don't want it as a decimal. We want that as a fraction so we can think in terms of exponents more easily. So that 0.01 is 1/100th. So I'm asking myself now, 10 to what power gives me 1 over 100? I'm going to write this one a little differently than I did the previous one. It's the same idea. Well, I know that 100 is 10 squared. And if I wanted the reciprocal, I would have to make that a negative 2. So my answer here is negative 2 because 10 to the negative second will give me 1 over 100. All right, we're going to do one more of these. How about log base 25 of 5? So this one I'm asking myself, 25 to what power gives me 5? This is a special one because maybe you're thinking, well, I know 5 squared is 25. Oh, but I'm supposed to put the exponent on 25. So what we can remember is that the square root of 25 is 5. And remember, the square root is the same thing as taking the 1/2 power. So this is actually 1/2. Okay, I lied. I do want to do 2 more because there's a couple of things that we need to remember. How about this? If I did log base 6 of 1, I talked about this at the beginning. If I'm taking 6 and I want to know what power I'm going to take that to get 1, anytime I'm taking the log of 1, everybody, we know that's 0, always. Here's an easy one. Log base 9 of 9. Remember when those are the same? That's 1. So these are big deals, all right? When you're putting 1 in, you will always get out 0. I do not care what the base is because anything to the power of 0 is 1. When these are the same, like here, you will always get 1. All right, cool. Moving on. Let's talk about inverses. So we're still in 6.3. And you have the instruction.